Section 1, the problem of distance, the need for a new long-haul champion. In the 1980s, the globe felt larger. Long-haul air travel was an established reality, but it was often a cumbersome and expensive affair. The dominant aircraft for these marathon journeys were large, four-engine jets like the venerable Boeing 747. While these planes were marvels of their time, they came with significant operational costs. They consumed vast amounts of fuel. Their complexity meant higher maintenance bills for the airlines that flew them. For passengers, the experience was often one of endurance, marked by loud cabins and frequently at least one layover on the longest routes. The world was connected, but the connections were not always efficient or direct. Airlines felt a growing pressure to find a better solution. They needed an aircraft that could fly far, just like the 747, but with better economics. The ideal plane would carry a substantial number of passengers, but use less fuel per seat. This would allow them to operate long-haul routes more profitably. It would also enable them to open new routes that were previously not financially viable with larger, thirstier aircraft. The market was signaling a clear demand for a plane that could bridge the gap between the mid-size wide-bodies and the jumbo jets, offering both range and efficiency in a single, well-balanced package. A new kind of long-haul champion was needed. Section 2. A collaborative blueprint. The birth of the 777. The journey of the Boeing 777 began in earnest in the late 1980s, but its genesis was unlike any aircraft program that had come before it. Instead of designing a plane and then presenting it to the airlines, Boeing took a revolutionary approach. It invited its key customers to become partners in the design process itself. The Working Together group brought Boeing engineers together with carriers like United Airlines, All Nippon Airways, British Airways, and Cathay Pacific. These airlines provided direct, practical input on what they needed from a new wide-body jet. Cabin width, payload capacity, range targets, cockpit layout preferences. The process was meticulously detailed and grounded in the real-world operational needs of the carriers. Boeing's design teams used this feedback to refine their concepts, creating a plane that was built for its customers, by its customers. This minimized the risk of building the wrong aircraft and fostered a sense of ownership among the launch airlines. The project was officially launched in 1990 as the Boeing 777. The development timeline was ambitious but methodical. It was the first commercial aircraft to be designed entirely on a computer. Using CATIA, engineers created a digital twin, pre-assembling parts virtually to check for interferences and ensure precision, reducing costly mock-ups and smoothing manufacturing. The first flight of the Boeing 777 took place on June 12, 1994, a milestone that showcased the success of this new design philosophy. Following rigorous testing and certification, the 777 entered service. On June 7, 1995, United Airlines flew from London Heathrow to Washington Dulles. The careful, collaborative vision was airborne and ready to shrink the world. Section 3. The twin-engine revolution. Key design choices. One of the most defining features was its reliance on just two engines for long-haul flight. At the time, conventional wisdom said transoceanic routes needed 3 or 4 engines. The 1980s and 90s brought big advances in high-bypass turbofan power and reliability. These new power plants were vastly more fuel-efficient and exceptionally dependable. The 777 was designed to take the largest, most powerful jet engines ever developed, sourced from General Electric, Pratt & Whitney, and Rolls-Royce. That two-engine configuration was the cornerstone of the 777's economic advantage, a design enabled by evolving safety regulations. Regulators established ETOPS, Extended Range Twin-Engine Operational Performance Standards, specifying how far a twin could be from a diversion airport. As reliability was proven, ratings were extended, and the 777 was designed to meet and exceed them. Its safety and performance earned a high ETOPS rating early, giving airlines confidence to fly the most direct overwater routes, saving both time and fuel. Beyond the engines, the 777's airframe incorporated innovations. Its wide-body fuselage provided a spacious cabin, and airlines could configure interiors to balance comfort and density. Engineers used advanced, lightweight materials, primary structure in aluminum alloys with significant composites in the tail and floor beams, reducing weight and boosting efficiency and range. The 777 cockpit leapt into the digital age with a glass cockpit and large LCD displays. The aircraft incorporated fly-by-wire. Pilot inputs became electronic signals that actuated control surfaces. Fly-by-wire made the large aircraft easier and more precise to fly, added flight envelope protection, and reduced pilot workload on long-haul missions. The arrival of the Boeing 777 had a profound and immediate impact on global route networks. Its unique combination of long range and excellent operating economics unlocked new possibilities. For the first time, airlines could operate profitable non-stop flights on routes that were previously too long or too thin for four-engine jumbos. Cities once linked only by layovers at major hubs could now be connected directly. Point-to-point international travel began to change how people and goods moved around the planet, making travel far more efficient. Major carriers deployed the 777 to replace older, less efficient jets like the DC-10, L-1011, and early Boeing 747. On dense transatlantic and trans-Pacific routes, the 777 matched capacity at a much lower cost per seat. That let airlines increase frequencies or cut fares, stimulating demand. Reliability and lower maintenance kept the 777 airborne more hours, the long-haul workhorse. The 777 wasn't just a replacement, it was a tool for growth, from primary hubs and even secondary hubs. Direct international service boosted local economies, strengthening business ties and tourism. Longer-range variants like the 777, 200LR, and 777-300ER pushed route limits further, enabling some of the world's longest non-stop routes. Airlines could link virtually any two major cities, creating a more interconnected network with fewer stops, shorter travel times, and greater convenience. The world map of routes was being redrawn, with the pen in the hands of airlines operating the Boeing 777.
From an aerospace analyst's perspective, the Boeing 777's impact can be understood as a victory in three critical areas: economics, technology, and network strategy. It was the convergence of these three factors that made the aircraft so transformative. No single innovation was solely responsible. It was the masterful integration into a cohesive platform. That holistic achievement cemented the 777's place in history as a true game-changer. Not an incremental step, but a new formula for long-haul success. Economically, twin-engine efficiency slashed fuel burn per passenger versus 3- and 4-engine wide-bodies. Fuel is a major variable cost, so savings went straight to the bottom line. Lower maintenance from 2 fewer engines and a modern design amplified the benefit, giving airlines a clear path to higher profitability on long-haul routes. Technologically, the 777 was a triumph of proven innovation. Mature engines and fly-by-wire, digital design with CATIA, and lightweight composites. Leading edge, not bleeding edge. The result was an advanced yet reliable platform from day one. Those economic and technological advantages enabled a strategy shift. The tool for route fragmentation and point-to-point expansion, often bypassing congested hubs. Instead of relying on 400-seat jumbos to fill mega hubs, airlines could build resilient, diversified networks. In essence, the 777 won the Triple Crown: lowered costs for airlines, unmatched reliability from mature tech, and strategic flexibility to redraw the route map. This is its core legacy.
The story of the Boeing 777 is the story of how modern long-haul travel came to be. Its influence extends far beyond the thousands of airframes built and delivered. The success of the 777 validated the twin-engine, long-range philosophy. It became the de facto standard for subsequent wide-body development, compelling competitors to respond. The industry pivoted away from four-engine giants toward highly efficient twins. Today, on April 15, 2026, the Boeing 777 remains a dominant force in global aviation. While newer aircraft like the Boeing 787 Dreamliner and Airbus A350 build on its legacy with more composites and advanced systems, the 777 continues as the backbone of long-haul fleets. Later variants, particularly the 777-300ER, are celebrated for payload capacity, range, and proven reliability, indispensable on demanding routes. The aircraft has proven remarkably adaptable. High-density passenger carrier, premium heavy transport, and highly capable freighter. The legacy evolves with the 777X, drawing from the 787, adding revolutionary composite wings with folding wingtips, powered by the largest and most powerful commercial jet engines ever built. The 777X is a direct descendant designed for greater efficiency and capacity. Boeing building on the 777 brand is a testament to enduring success, a dynasty, not just a model. In conclusion, the Boeing 777 brought the world closer together. By solving range, capacity, and cost, it made long-haul travel more affordable, comfortable, and direct, born from collaboration, built with digital tools, and powered by an engine revolution. Look up at the direct contrails across oceans and continents. That is the world the 777 helped create. It truly is the jet that shrunk the world.